Hello everyone, myself Sravanthi, working as Assistant Professor in the Department of Data Science and Cybersecurity in MLR Institute of Technology. Today our topic is conversions of finite automata to regular expressions. Conversions of finite automata to regular expression. There are two popular methods are there for converting a DFA into its regular expression. So to convert a given finite automata to regular expression, there are two methods are there. The first one is state elimination method and the second one is Arden's method. There is a Arden's theorem. From that Arden's theorem, we are going to take the formula and we are going to apply over here. So these are the two methods that are used for converting a DFA to its regular expression. So the next one is Arden's theorem. The next is Arden's theorem. So there are two methods are there. The first one is state elimination. We have done. The next one is Arden's theorem. So Arden's theorem popularly used to convert a given DFA to its regular expression. So what are the steps? So this is a Arden's theorem is there. From that Arden's theorem, we are going to use two formulas to convert the finite automata into a regular expression. So let's take P and Q are two regular expressions over sigma, nothing but alphabets. P does not contain a null string epsilon. P should not contain a null string epsilon. Then this is the form. If I find in my diagram, in my DFA diagram, if that form, it is in the form that we are going to convert the given DFA into equations. If I find the equations are in the form of P equal to Q plus RP. If I find any equation, it is in the form of these, then we are going to write it as R equal to QP star. See, if you find, if P does not contain a null string epsilon, then R equal to Q plus RP has a unique solution, that is R equal to QP star. This we got from the Arden's theorem, this formula. Next, what are the conditions? The transition diagram must not have epsilon transitions. Nothing but here we are not going to use NFA with epsilon, because the diagram, if I find epsilons, that is not used to find the Arden's theorem. Why? Because see here, if P does not contain null string, if I find a null string in my diagram, then I cannot find the regular expression. So there are the two conditions. The transition diagram must not have epsilon transitions, and there must be only a single initial state. Multiple initial states should not be there and no epsilon should be there. So first step, from an equation for each state, considering the transitions which comes towards that state. So what it is meaning is, suppose I have a diagram Q1 and Q2, here A and some B, and here it is B. So what it is, from a given equation, for a equation for each state, considering the transitions which comes towards that state. See here, what are the incoming edges? For that we are going to write the equations. See here, Q1, I am having a self loop B. So Q1, for the first equation I am writing, so start state Q1 equal to, what are the incoming edge? Q1 dot B. Q1 on B input, it is going to Q1 itself. That is the meaning. Q1 dot B is nothing but Q1 on B input, it is going to Q1. Next, what is the still incoming edges I am having towards Q2 dot B plus Q2 dot B. Because from Q2 on B input, it is coming to Q1. So the next one is add epsilon in the equation of initial state. For the initial state, we are going to just add epsilon. Even we have an equation, we are going to write epsilon. Next, final state should be in the form of R equal to Q plus RP to get the required regular expression. To find the regular expression, when we are writing the equations in this form, for not only one state we are writing the equation. If in my diagram 5 states are there, 5 equations should be written and we should find the regular expression. The regular expression will be formed from only the final state. We are going to find out the target is our final state. By using the final state, we are going to find the regular expression. Note, Arden's theorem can be used to find a regular expression for both DFA and NFA, but not NFA with epsilon. If there exists multiple final states, for example, in my diagram, in my DFA diagram, if I find more than one final state, then we are going to find the equations and both the equations are combined to give a single expression. Write a regular expression for each final state, add all the regular expressions to get a single final regular expression. If we find multiple final states, we are going to combine to give a single regular expression. So it is applicable to both NFA and DFA diagram. See, the first one, A, B. So first what we need to do, we need to write the equations. Any incoming edge towards the state. So only single initial state. Yes, single initial state is there. Only one final state is there. So let me write the equation for first one. So what is the A? A is my start state. For first state A, I am going to write the equations. What are the incoming edges? B dot 1. On B on one input, it is going to A. Plus, as it is, A is our initial state, we are going to write epsilon. So this is our first equation. The second equation, next state what I am having? B. B is our next state. So any incoming edges towards this? A on 0 input, it is coming to B. A on 0 input, it is coming to B. So what it is? This is our second equation. What is the final state here? B is our final state. So by using these B, we are going to find the regular expression. So substitute A, nothing, substitute 1 in 2. So B equal to, instead of A, I am going to substitute 1. B dot 1 plus epsilon dot 0. So what I am going to get? B dot 1 0 plus epsilon dot 0. This is B. So epsilon dot 0. So what I am going to have here? Next, what is in the form of? So Arden's theorem, what it should be in the form of? R equal to Q plus RP. If I find the equation in this form, then we are going to write it as R equal to QP star. So see here, we can write these as R Q R P. So what I can write? B equal to, it is in the form of R equal to Q plus RP. So next I can write it as QP star 0, QP star, nothing but P star. P is nothing but 10 whole star. So epsilon into 0 is nothing but what I am going to get here? Epsilon into 0 is nothing but 0. 10 whole star. So the regular expression we are going to have is, 0, 10 whole star. 0, 10 whole star. Right? 0, 10 whole star. So this is the regular expression we are having for this equation. So first we are going to write the equations. After writing the equations, we are going to check whether it is in the form of this. If it is not in this form, we are going to substitute. Then after checking this it in the form, if I find that in the form, we are going to write it as R equal to QP star. So then we got this one. Next theorem, Arden's theorem. So the second equation, check any states coming towards that state. So only one initial state, only one final state. There is no epsilons here I am having. So check any state coming towards Q1, no incoming coming. So any states, there is no. So first let me write the equations. Q1, Q1 is there. Q1 is equal to, so any incoming? No. So directly I have epsilon. Any state, any inputs coming towards Q1, no incoming. So directly epsilon. As Q1 is my start state, I am writing directly it as Q1. Next, only epsilon. The next state I am taking is Q2. Q2 is equal to Q1 dot A. So for Q2, from Q1 on A input, it is coming to Q2. So Q1 on A, it is coming to Q2. Next, still anything? No. So this is our second one. Next, Q3. So Q3, what are the states it's coming towards Q3? Q1 on B input, Q1 on B input, it is coming to Q3, plus Q2 on A input, it is coming to Q3. Next, Q3 on self, Q3 on A, it is coming to same. So this is nothing but third equation. By substituting, we need to make that equations in the form of Arden's formula, R equal to Q plus RP form. So here I have epsilon, here I have this one. So better I am substituting 1 in 2. Substituting 1 in 2. So Q2 equal to epsilon dot A. Q2 equal to epsilon dot A. So this is my fourth equation. Now substitute this in this. Epsilon into something is nothing but I am going to get it as A. Right? So now substitute 1 and 4 in 3. As Q3 our final state, we are going to find the regular expression from Q3. Okay, that should be kept in mind. So the Q3 is our final state. So we are going to find from the Q3 only the regular expressions. Q3 is equal to Q1. So what I am having, Q1 is nothing but epsilon dot B plus Q2 is nothing but AA plus Q3 dot A. So I can write it as epsilon into B is nothing but B. So nothing but null string into B is nothing but B. So B plus AA plus Q3 dot A and Q3. So it is in the form of R, Q, R, P. R, Q, R, P. So what I can write, if it is in the form of R equal to Q plus RP, we are going to write it as R equal to QP star. R equal to QP star. R equal to QP star is nothing but R is Q3, Q is nothing but B plus AA star. P star is nothing but P is A star. So the regular expression for this grammar is B plus AA whole A star. So this is the regular expression for this finite automata. So first we found the 3 equations because 3 states. How many number of states are there? That many equations we are going to get. Arden's theorem. So this is one more diagram. Here I have 2 final states are there. So let me write the first equations. How many states are there? 3 states are there. Q1 is equal to, so any incoming Q1 on 0, it is going to Q1. Okay, plus epsilon. Q1 on 0 plus epsilon. This is our starts equation 1. Next, Q2. So Q2 from Q1 on A, it is going to Q2. Q1 on 1, it is going to Q2. Plus Q2 on 1. Q2 on 1, it is going to self Q2. Still anything? No. So this is our second equation. Next, Q3. Q3 is equal to any Q2 on 0, it is going to Q3. Plus Q3 on 0, it is going to self Q3. Plus Q3 on 1, it is going to Q3. So this is our third equation. So what are the final states here? I am having Q1 and Q2 are the final states. So by using these two final states, we are going to get a single final regular expression. Check whether it is in the form of R equal to, so I am taking the first equation. Take first equation, Q1 is equal to epsilon plus Q1 dot 0. So how it is in the form? R equal to Q plus RP. R equal to Q plus RP. If it is in this form, we are going to write it as R equal to QP star. So R equal to QP star is nothing but Q1 equal to QP star. So Q is epsilon. P star is nothing but 0 star. So we can write it as 0 star. Q1 equal to 0 star. So the next one I can take this one. Second equation. Q2 is equal to Q1 dot 1 plus Q2 dot 1. So how I can have? So the Q1 can be replaced here with 0 star. 0 star dot 1 plus Q2 dot 1 is equal to Q2. So it is in the form of R, Q, R, P. Rp. So how I can write it is R equal to Qp star. So this is my fourth equation. Now Q2 is equal to 0 star 1 P star. P star is nothing but 1 star. P star is nothing but 1 star. Qp star. 0 star 1 Qp star. So this is nothing but my fifth equation. This is nothing but my fifth equation. Now what we have discussed in the steps. So if you find more than one final state, combine those two final states and make it as a single regular expression. So what I am having, R1 equal to, R1 is nothing, what is, so combine fourth and fifth equation. I am combining, so 0 star plus 0 star 1. So we can write these equation in this form also. So how we can write it is 0 star 1, it is nothing but 1 star. 0 star 1, 1 star. So what I can write, 1 into 1 star, R into R star. We can write it as R plus, we have seen from the regular expression, 0 star 1 plus 0 star 1 plus 0 plus 0 star 1 plus. So the regular expression combine 4 and 5 equations. 4 and 5 equation. 4 is 0 star and 5 is 0 star 1. So the regular expression we got is 0 star plus 0 star 1 plus. So this is the regular expression for this grammar. Yes. So we have seen today finite automata to convert finite automata to regular expression using the state elimination method and the Arden's theorem. So these are the few examples which we have discussed. Coming to the state elimination method, we are going to check how the starting state, if an initial state have any incoming edge, remove or create new state. If I have multiple final states, create new state and make that new state as a final state. And if you find the final stage any outgoing edges, create new state and make it as a final state with epsilon modes, nothing but 0 modes. And by using that, we are going to remove all the intermediate states, and finally we will be having only the initial and final state, and then we will get a regular expression by removing the intermediate nodes or intermediate states. That is for the state elimination method. So coming to the Arden's theorem. The Arden's theorem is nothing but here we are going to write how many number of states are there, that many equations we are going to write, and we are going to bring that equations. It is in the form of R equal to Q plus RP form. If we find these in this form, then we are going to write it as a QP star. So the final state, which state is having the final state, by using that final state, we are going to write the regular expression. Here I have Q1 and Q2 are the final states. So for these two states, I found the regular expression. But Q3 is not final state. I am not substituting here in 1 and 2 because I am here the Q3 is not used in first equation and second equation. So mainly I concentrated on 1 and 2 equations to get my regular expression. This is about the conversions for finite automata to regular expressions. Thank you.